Mehta School of Data Science and Artificial Intelligence has been recently established at IIT Guwahati with the aim to promote research and teaching and skill development in these areas. Dr. Santosh Kumar Viparthe is known to me. He is, in fact, we have been collaborator for a long time now since we started this series on machine learning for computer vision and deep learning and application. Dr. Viparthe was very much there with me. In fact, he was the main force behind running these programs successfully. And only recently he has shifted to IIT Guwahati. So he did his MTech and PhD from IIT BHU in 2010 and 2014. And he is actually having a electrical degree in electrical and electronics engineering from Andhra University. He has done research in various areas, but the main area revolves around, like all his research revolves around computer vision and machine learning. He has developed some wonderful algorithms on deep learning, on emotion detection, macro analysis, micro analysis, change detection, and think of any important journal in these areas. He has published his research in this, including IEEE transactions and many other important areas of research. So basically you can see that his work is, whether it is aerial image analysis or expression analysis or image retrieval or motion detection, face recognition. Think of any important research areas, you will find one research paper, important research paper by him. I'm so fortunate that I have worked with him for a long time now. I think several years have passed, although only virtually in connection with
the impacts of those architectures in few applications we're going to discuss. So transfer learning. So the name itself is saying that we would like to transferring knowledge which you have gained in X, and you are transferring that knowledge to the another application called Y. So transferring the knowledge of one model to perform a new task. So this is something also called as a domain adoption. So now why we need to do such type of concepts of transfer learning, especially in the deep learning algorithms? In which situation it is going to help us? Generally, you might hear about the one of the biggest database that is called Imagenet dataset. So Imagenet dataset, it is having a huge number of samples. If you want to train any of the model, you need huge amount of GPUs are required. So minimum you need 256 GPUs are required to complete the process within a 1 hour. But we doesn't have that much of infrastructure to solve or run our models on a bigger datasets like Imagenet. So if we will adopt the concept of transfer learning, then it will be cheaper and faster to use this concept in another applications. So this is some properties of Imagenet dataset. If you can able to see the comments of Sammy Bangio from Google Research Scientist, he stated that the Imagenet dataset size is by far much greater than anything else available in the computer vision community, and thus helped some researchers develop algorithms they could never have produced otherwise. Because this Imagenet dataset is one of the very biggest dataset, and which is developed by Fifi Lee. She is a professor in Stanford University. Their research group has developed this particular dataset that is called Imagenet dataset. And this particular dataset was initially presented in 2009 CVPR conference in Florida. And this dataset is having 14 million images, out of which is having 20,000 categories. So 20,000 categories is not a simple thing, and each category is having almost 1000 images. So as it is having this diversified patterns are available, or diversified classes are available in this particular image dataset, Imagenet dataset. So training and any of the algorithm, deep learning algorithm, is one of the biggest challenging in nature. It's very challenging to develop and design a particular model so that it can able to understand these diversified features. So in order to run your model on this much of the big data set is one of the challenging scenario. So if you can able to see some of the architectures which are available in the literature. So this is a Vigisnet 2014 dataset. The VGC represents visual geometry group. Here they have initially in Vigisnet 2014 dataset, which is an enhanced version of Aict and the ZFnet. Here, if you can able to see the architecture, this is a sequential architecture with a uniform 3x3 filter size they have used across this particular architecture. But in the previous cases like Aict and all, they have used 11x11 filters and 7x7 filters and so on. So 11x11 filters they are used in the Aict and 7x7 size of filters they have used in the ZFnet. So here a deep architecture, but it is a sequential one where you have used the uniform filters of 3x3. Similarly, in 2014, the Googlenet has introduced a new module that is called Inception Module. So Inception Module, the importance of this Inception Module here is you can extract multi-scale features. So what is here my multi-scale features? So in the previous VGC, if you can able to see the VGC 16 architectures, here the uniform filter of 3x3 is used across. Or in other architectures, they have used either 7x7 or 5x5 or 11x11 and so on. That also in a sequential manner. But if you can able to see in this particular Googlenet architecture, they have used multi-scale filters where 1x1 will going to do some type of a point processing operation, and 3x3 will going to do like a neighborhood operations at a radius of 1, and 5x3 is going to do the neighborhood operation or mask operations with a radius of 2. So if you can able to see here, 3x3 is going to extract some features from a given input data. 5x3 is also going to extract some receptive information from the given input data. 1x1 also going to give some information. But at the end, you are going to combining all these particular multi-scale features together here to train your models. What are the advantages of doing this? How it can able to affect the performance of your model? We're going to discuss late in some time with some pictorial representations. So in 2014, there is another architecture was there that is called Resnet 2014 architecture. Actually, the Resnet has won first prize in ILSV RC 2015 classification competition. And if you can able to observe in the object detection concepts, in place of using this VGC 16, they replace the VGC 16 with Resnet 101 as a backbone model in the faster RCNN. So in the object detection, we have a backbone model was there. In backbone model, to extract the features, initially they have tested with the VGC 16 architecture. In place of VGC 16, now they replaced with the Resnet 101. And by using these residual connections, they got the better performance. So what is meant by residuality? If you can observe this particular diagram here, residuality, you have some given input data X. You are trying to pass this information to the second layer, that is called xt+1. Also, you are going to extract some extra features and you are going to merge it after some time. So the previous information you are trying to add after some extent of time, therefore the feature should not be degraded or nullified. What is the meaning of feature degradation and all? That also we are going to discuss. Now you try to observe this particular architectures here, which is 19 in a sequential manner, and there are another model with a 34 layer is also in sequential model, and this is called Resnet model, Resnet 34, where you can able to see the residual connections. You try to observe here the residual connections here. The from a given input data, extracted some convolution operation, that is with the help of 7x7 convolution operation. What are the features you got it? The 7x7 receptive responses are again added at the third convolution response. Again, the third convolution response output is again added at the fifth, and so on. That means, as the depth of as the model goes deeper, the previous informations are going to be added. Therefore, the features whatever the model is trying to learn, it will not going to be vanish. Why it will going to vanish? We will going to see. Now later on in 2018, if you can able to see, these are all the very deeper networks and where the number of parameters are very high. To use this particular robustness of this deep learning concepts for compact device use like mobile, in your mobile, if you want to develop an algorithm, the existing architectures may not going to help you because it is going to take a lot of time. So researchers have developed a compact and shallow network that is called MobileNet. So the MobileNet aim is to develop a very small network with minimum number of parameters to get some better performance. With that intention, the MobileNet has introduced in 2018. Now let's analyze what actually will going to happen if you apply a sequential network, or what is the advantage of using the residual connections and so on. Let's assume this is my given input data. We are trying to extract some 3x3 convolution operation by using some X filter for easy understanding. You got some features. As it is a deep network, let's assume I would like to do the second convolution operation on the first response. I got this response. As it is a deeper one, I want to repeat the same operation third time. So I got this response. So if you can observe this, what is your observation after 3 times repetition of the convolution operations? Initially, in the first convolution operation, the edges are going to be detected, but in the second convolution operation, the edges are smoothing. But in the third convolution, the information is going to be ignored, or information is going to be lost. So if you keep on repeating the operation in these type of applications, for example, you might be expecting the informations are going to be preserved as going deeper, but instead you are going to lose the information here. So then how come this particular residual connections may going to help us? So in the previous case, like a sequential, let's assume the given input data, the same filter of 3x you have applied, you got some output, you have done some second convolution operation on the same thing, this is a response. Now, third time, this is a response, right? Now what we're going to do is, whatever the first response is there, what are the first receptive responses we got it here, those things are going to be added after the third convolution operation. Now, after the third convolution operation, with the help of this residual connection that is called skip connection, after adding this, we can able to get the information here. You can able to see it here. Here, the information is still preserved. If you can observe the responses at the third convolution operation and after residual connection, what are the output you got it. So, if you want to develop a deep CNN model, but you are intended to not to lose your information, then these skip connections or residuality will going to help us. Therefore, these information can be further fed to the next level, so the model may able to learn. Let's assume if you are going to do one more operation on this image only without residuality, you may going to end up with some uniform response. Instead of getting some edges, all the edges are going to be filtered out and the uniform response we are going to get it. Okay. In order to further analyze this concept, why it is so happening, let's take a very general observation. We have our album photo, color photo. Let's assume that color photo might be having some chalkies powder or some powder, some noise was there. The first thing what you're going to do, you want to remove the dust particle, so you're going to rub it. So removing the dust particle is something like a filtering operation. So first you have applied the first one. Once you have use a kerchief or in any napkin to remove the dust, then assume the dust has removed. You like that operation, you keep on repeating this operation again and again and again in the same location. Instead of removing the noise information or dust particles, you can also going to remove the actual information. So that is what going to happening in the sequential structures. Now there was another alternative thing we also need to do is, do we need to go only for the sequential structures? Can't we go in a parallel structures? Then how come it can help us? Now if you can able to see in a sequential structures, instead of sequential you can go for the parallel structures here. So from a given input data, we have applied 3 different convolution filter operations. So we got some 2 different responses. Once I going to combine this, I can able to get the better information also. So you want to do 2 convolution operations. Instead of going in a sequential one after other, we can use this particular parallel structures also, so that we can able to get the information. We can preserve the information. Also, the computation time also going to be reduced. Now, further question also comes here is, in these examples we have discussed on a 3 cluster convolution uniform filter size. What if we use multi-scale filters? Like what are the Inception model we have seen earlier? There they are using this 3 different type of filters and they're going to use it. Now we can also going to use this multi-scale filters here. Now try to observe here. This is the 3 class C convolution operations uniform filter. This is the response on a same given input data. 1 filter of 3 class C we have used, and similarly another filter of 5 class C we have extracted. If you can able to see the responses with the help of 3 class C and 5 class C, the edge informations are different. Because here at a neighborhood of in 3 class C, with a reference point at a radius of 1, it is going to consider the neighboring values. But in the 5 cross 5 convolution operation, at a particular reference point, we are going to take the neighboring at a radius of 2. So from a reference point, you are going to take the neighbors at a longer distance. So in the 5 cross 5, you may be able to get the major changes. But in the 3 class C, you can also going to get the minor changes also. So whenever we are going to integrating these 2, we can able to get the resultant response like this. So here one thing we need to take care while developing an algorithm that. So as you know, this convolution operation, whenever you are applying a convolution operation without padding operations, then the boundary information may go into effect, right? The resultant response size may go into effect with respect to the given input data. But here we need to be very careful that the resultant response of 3 cross 3, also the resultant feature map size of 5 cross 5, the size should be remain same. Then only we can able to do these particular operations like addition and so on. Similarly, the case which we have discussed in the residual connection also here, we need to be very careful while doing these residual connections. So before pooling operations, we need to go for these residual connections so that the dimensionality issues may not going to happen. That one observation we need to be we need to keep in our mind while developing any of the algorithm. Now, how come this transfer learning? These are all the few existing architectures and the limitations. Now, how come this particular transfer learning will going to help us? Here the intuitions are so simple of using the transfer learning. So we knew this VG16 and all these popular networks, Google Net or Residual Net or any network, which they have trained on a diversified data sets and very big data sets. Will you decide the number of layers to be skipped? Will that be also be hyperparameter? How will you decide the number of layers to be skipped? Yeah, how to decide the number of layers to be skipped? That we will going to discuss. Yes, we're going to discuss on that. Now here, if you can able to see in the transfer learning, the basic traditional approaches for a given application, you have 3 classes. If you want, you can able to run the different networks on 3 different models. But in the transfer learning, if one model you have already seen different categories, you can adopt that and you can test in the new application also. That also can be possible, because your popular algorithm VGC16 or Resnet, they already know how this particular, for example, I'm talking about those algorithms already know how the circle will looks like, how the triangle looks like, so that you can also use these particular models and you can also test in a new application. This also can be possible. And such, similar type of things have already done in the literature. We're going to discuss few of the articles, popular articles. So in the transfer learning, we have 3 different types. One is the inductive learning, transductive learning, and unsupervised learning. What is the unseen for the transfer learning? Unseen data for transfer learning. See, unseen data is nothing but you are going to test your models on completely not used during the training. It means that you have used some X data. Suppose you have trained your model on, let's assume we have 10 breeds of dogs. You have tested your model on 7 breeds and 3 breeds you have not even tested. Okay, but you are not even used in the training. That is called unseen data. Seen data is nothing but the similar content which is available during the training, also in the testing. So whenever you are going to use the same data during the training and testing, that is called seen data. So whenever you are going to test our models on the seen data, the performance will be always better as compared to the unseen data. But to develop any of the model for the real-time purpose, we need to develop our model which is going to perform best in the unseen environment also. So that is how we are actually trying to run our models. Now, yeah, how we can able to go for this particular transfer? Okay, fine. Now, how to do this particular transfer learning? Okay, let's take a simple example with pictorially. We can do this particular transfer learning in 3 different ways. Let's think about it. Let's assume this is one network, VGC16, for example. So VGC16 is having, which is trained on Imagenet dataset, which is having 1000 classes. But let's assume I want to use this particular model for expression recognition, for example. So in expression recognition, I need to use only 6 classes or 7 class problem. Or you want to use this particular VGC16 network for your cat and dog classification. It can be possible, only 2 classes. Now, this particular Imagenet is having all varieties of objects, whether it can be cat, dog, human faces, and so on. So this model is already tested on a diversified environment. So the weights of this particular network is pretty good. Now you want to adopt this. So we have 2 options are there. Take this particular network weights as this. Take this network completely. Then you just only freeze those weights. All the weights you can take it and freeze those weights. At the end, fully connected layer, what are the fully connected output neurons are there, only you can do the back propagation. So by freezing the weights of the already trained VGC16 model and only train your model at the fully connected layer, that is also one possibility. Later on, if you want to do the fine tuning, then you can unfreeze the weights. Initially, instead of using this random initialized weights, instead of using randomization, you can use this particular already pre-trained weights as a inputs to the model, and you can train this thing to you can fine tune these weights as per your application. That is one case of transfer learning. There is another case of transfer learning is that I knew this is 16 layers of convolution operations are used in the VGC16, but I don't want to use the rest of the layers. Initially, only 2 layers I want to use it. So you can use the initial 2 layers from the VGC 16 model or Resnet model or whatever the model you want to use it, you can take those only 2 layers and freeze those weights, because these weights have already trained enough to extract the required features from a given input data. Maybe the application might be different here. So that's why initially you take only 2 filters, 2 weights which are already trained, and you can then you can use the customized filters. What type of different network you want to use it, you can do that, and you can do the back propagation, and you can train these weights in the newly assigned filters. That is one case. Or in another case, you can simply unfreeze the weights and you can able to do the fine tuning also. So transfer learning, the main intention of using this transfer learning here is to your training process can be a bit faster, so your model can easily converse. So this is what we are talking about here in the feature extraction. What are the pre-trained weights are there? Let's assume I want to extract the features for the happy face here. For the happy face, I am going to use the VGC 16 here. For example, I will going to get the features that's called before fully connected. What are the features are there? Those features I am going to use it as it is from the VGC 16. But at the end, I need to change the class file, because the Imagenet is having 1000 classes, but my application might be having 6 classes or 7 classes. So 1000 classes I cannot able to use it. So I need to train only for the class file. That is one case. Or in another case, I can do the completely fine tuning by back propagating to the given first layer also. That is called by unfreezing the model, you can able to do the back propagation. That is called fine tuning. Another one is only simply transfer learning. Now the question comes here is, so somebody told me that how to decide the network layers. So that deciding of the network layers are purely depending upon an application. For example, just I have given you an example in a sequential layer network. For facial recognition or facial express recognition, if you're going to do the deep CNN model, you might be expecting the better results, but you may not going to end up with the better results. You may going to end up with the worst results. Reason here is, if you go deeper and deeper, the features are going to be ignored, as I have shown in the previous diagram. Like 3 times you repeatedly do the convolution operation, instead of extracting the edge information, you may going to lose it. But so in such applications like facial express recognition, if you see the papers, most of the papers, they will try to use the shallow networks. But if you can go for the applications where you have many changes are available, or diversified features are available in a particular given input data, then maybe you can go for the deeper networks. So selecting a network depth is purely depending upon the application where we want to apply. Similarly, for this particular transfer learning also, let's assume suppose we have a model A trained on a dataset A. How do we apply this transfer learning to a dataset B to create a model B? Because Imagenet dataset is, for example, is there, you have already model is already trained, but now you want to use that particular model in another dataset to get the results. That is your target, let's assume. Then these are all the things we need to consider in our mind. Let's assume your A dataset is very larger in size, and the B dataset is completely different properties. That is also, so there is no similarity between the X dataset and there is no and Y dataset. That's why A and B are not having any similarity. Both are completely dissimilar. In that case, how to use a transfer learner? So the simple thing is that train model B from scratch, initialize the weights from the model A. Instead of using this transfer learning, you can use the weights of the model A and you do the training from the scratch. Because A dataset and B dataset both are completely dissimilar. But now let's assume the case where your dataset A and the dataset B having some similarity. Both are having similar, but number of classes might be different. The visual properties are almost same. Then what to do? In that case, you need to just only do the fine tuning, because model A is already well trained with n number of classes. So model B might be having limited number of classes. So simply you can do the fine tuning, because the model A is already well trained enough. But now another case is the model A is trained on a smaller data set and B is having dissimilar features. Model A is already trained, but the trained on a very smaller data set, and you have a data set called B, and the visual similarities are dissimilar. There is no similarity between the two things. Then train the cluster using the earlier layers. Later layers won't help you much. So in that case, whatever the model A is there, just you take the 1 or 2 layers from the model A. The rest of the layers you can decide as per your requirement. And both models are smaller in size, and both are having similar properties. So there is no need to train the model. So it will not going to help you. So depending upon the requirement and availability of the data, we need to take a decision. And also the model you are going to choose, the model parameters you want to choose or model weights you want to choose, then we also need to analyze that where that particular model was trained and what type of features it has, it learned. That also we need to observe. That means not only selecting a model is important, and also to study where that particular model was, what type of data that particular model has used is also an important parameter before utilizing this particular concept. So these are all the few articles which are available in the literature, if you can able to see, especially on the expression recognition. This is completely on transfer learning models only. Still some of the articles you can able to see with the help of transfer learning. Let's try to analyze this particular article here. So here transfer learning for micro expression recognition. Now you see, so we will going to discuss more in detail about the micro expressions and all in some time. But here the micro expression where these motion informations are actually required. So they have, in this particular article, if you will observe here, before using these particular features, they need to do some pre-processing here. So they have used this motion features with the help of this optical flow. Now you observe here. So from here they got some of the inputs. They have used the VGG16 convolution blocks. So that as is, what are the VGG16 pre-trained weights are there, those weights simply they have used here to extract the expression features. And at the end they have used some of the LSTM that to learn the temporal features. That is different. But if you can observe here, in the space to extract the spatial features, they have adopted this particular VGG16. Also they have used multi-level features also. If you will observe here they have used only one VGG16, but later they have used different VGG16 modules here in 3 parallel streams, and they finally concatenated all the things together. By using this VGG16 model weights as is, you can also find the different features. And here another paper, emotion recognition on small data set using transfer learning. So whenever you have a very smaller amount of data is available with you, now if you observe here, instead of depending upon a single VGG16, in this article they have used both VGG16 as well as the Aict. And we knew this VGG16 and Aict they have trained on Imagenet dataset. Now those weights they have used and tested on different data sample size. You can observe here, initially 28,000 images they have used for the training. Later they have tested the model on 32 images, 32K and so on. And at the end 1K also. So here if you will observe here, all the things are happening on a similar data set called FER. So the redundant features they might be extracted, that is their approach. So initially they have done this for first tuning, and later they have done the similar thing for the second time. So you can speed up the process of learning with the help of the transfer learning. So if you can able to see, there are many articles are there in the literature. This is the third model with this I'm going to close this transfer learning. VG16 model, then you use a pre-trained model weights, and you crop the image, you crop the face from a given data, then what are the pre-trained weights are there, then you do the fine tuning and you got this particular emotion model, then you simply do the testing. So the advantage here is you no need to train for n number of times. The model will going to converge very faster if you're going to use the transfer learning. Now there are few other articles also there, like first they have trained their models on macro expressions, and by using those weights they have again operated on the micro expressions. So if you can find a number of transfer learning models on different applications, and one more algorithm will going to show after some time in that action recognition also. Now what are the different applications we have, and how we can need to develop the algorithm. Now if you can able to see it here, image retrieval is one of the one application where we can use in many other applications also. So image retrieval, you have a huge amount of data is with you. You would like to retrieve the relevant information from based on the image query. The idea is so simple like this. Let's assume if you are going for a world tour, per day you are going to take the selfies of maybe 200 selfies, for example, per day, and your world tour is for the 30 days, so you can count how many number of images are there. Now you want to collect only your pictures from a world tour trip. You might be having many images with you as a database, but you want to extract only your information. One option is to do manually, and other option is to just you pass your face as a query to the model, and wherever your face is available in a given image, those pictures are going to be retrieved. That is called image retrieval. And this application can be used in many places, like in the medical image retrieval, it's going to play a very important role. And some commercial part also we can use this image retrieval. And let's assume you can able to go for this Amazon mobile app and Flipkart mobile app. There you can able to search the product by taking a picture. Just you upload a picture and relevant items which are available in the Amazon dataset, it can able to retrieve and it is going to show on your screen. So there also these image retrieval applications are going to be used. The another thing is called object detection and classification. So object recognition you can say. So object detection, if you will observe here in this example we have different objects are there, and few objects are moving and few objects are not at all moving. So there are few static objects are there. Also there are movable objects also there. Now that is your task to recognize what type of objects. Do you want to if we are aiming to detect an object given in a frame, where it can be static or moving, that's pretty fine. That is called object detection. And you also want to know what that particular object is, then it is object recognition. You need to detect and also you want to classify, then it is called object recognition. Just I want to ask you that are you able to follow me? Or if you have any questions, please you can message me. If you have any questions on transfer learning, you please discuss with me. Then we can.
Yeah, you can put in the chat box, or if you raise hand, we will be able to.
Yeah, please, Lakshmi ji, बताइए.
Any questions, participants? It's okay. They are saying some. One person has raised hand.
Yeah, Manjunath ji, please बताइए.
Manjunath, ji?
Yeah, sir. Actually, I wanted to ask, like, I have taken an image from some instrument.
Okay.
And trained on some feature. And from another instrument, I take the resolution will be different, like very good resolution. The same, there we can use the transfer learning, right? Like we can use the weights and all for this. The features are same, but they are taken from different instruments.
Okay. What was your ultimate aim? And you have trained with low resolution image and you want to test on the high resolution, or vice versa?
Yes, like that, like high resolution image. Like,
yeah, you can do that. You can use the transfer learning. Even you don't need to even use the transfer learning also. Directly you can test, because the instrument properties are remain same.
No, the instruments are different. No, so it's actually high resolution image, but the features are same.
Yes, we can use it. You can initially you can use this transfer learning weights, and then you can, if you require, you can do the fine tuning also. That is easiest way. Instead of training from scratch, you can use the similar thing.
That's what I wanted to ask.
Yeah. With that we can do it.
Yeah.
Can we train two different problems using a single network like joint learning? Yes, we can do that, and some of the things we can discuss. But how much these two problems are? Do we have any some sort of common relation between these two problems? Then it makes some sense. Or if there is no completely two dissimilar things, then it will be a question mark. Single network like joint network. Yeah.
There is another question by Manojit. So I am asking you to unmute yourself, Manojit.
Okay, thank you. Hello.
Yeah,
Yes,
please.
Actually, sir, I have one classification problem. I am using some pre-trained model. Now, in this pre-trained model, I want to reduce some. They have some redundancy. I am thinking that they have some redundancy if I use more than one pre-trained model. So, to get better classification model, sir, what to do and how to remove this this redundancy?
I didn't understand the question. You have used multi different models.
Sir, actually, hello. Yes, sir. Sir, how we can remove the redundant feature from the various pre-trained model like Inception, VGG19 or Resnet for a specific classification problem?
No, question here is like suppose this VGG16, Resnet and all, they have shown their efficiency in Imagenet dataset, right?
Yes, sir. Yes, sir.
So
Yes.
that is different case because every model has advantage and disadvantage. Suppose residual net, you may going to get the better features, but as the features are there, even though it go deeper, it will going to give you the better results. So that is what they have already proven. Now coming to your application, in which sense you are talking about the redundancy?
For the sir X-ray image, so I want some if have some similar feature, if I want to detect some similar feature if this pre-trained model having.
Okay.
So how to remove this redundancy, sir, or how we can say the feature or similar feature available in the as output from this model?
So actually question is not clear, Manojit. Santoshji, can I add here to what he's saying?
Yes, ma'am.
Perhaps he is looking for some redundancies which appear in the feature maps. And so this is, why do you want to reduce redundancy is not clear to us, Manojit. What is your purpose of reducing redundancy?
Ma'am, to make the system, make a model better classify for a particular problem domain, like I'm working on the X-ray image. So to better classification, I want to identify if there is any similar feature in this model.
I think you might be trying some X model and you might be got overfitting of it. I mean, how you decided that you got a redundant feature?
Actually, sir, I want to, sir, when I train this model, when I compile this model in a Imagenet, they are giving some accuracy, and now I want to do some updation on that.
Okay,
updation like
you are using the existing network to directly you have tested your model, you got some X result, but you want whenever you are trying to train the model, you are not getting the results. Am I right?
Yes, sir.
It is not about the redundancy, because that is where this particular VGG16 and we are using this transfer learning, because the VGG16 and the models which are trained on Imagenet, they definitely can able to extract some features, because the weights are trained enough to extract the features. So whenever you are using those weights for your data set, it is giving some X percentage. Maybe it might be good or bad. But if you want to do the same model from the scratch training, it may going to give you the 0% of improvement. Are you going to get the same problem, right?
Yes, sir.
Because your data is not sufficient enough to train the model. That can be the first case. Or the second case is that network is not suitable for your application, because not necessarily all the popular networks, if you going to train from scratch, may going to give you the results.
Yes, sir.
Okay, that problem is there. That is the reason we are going to develop an individual networks as per our application. You can use the initial 2 layers or initial 3 layers of the VGC16 or any features. You can use those weights. Then you can able to do this particular fine tuning and so on. That you can do it.
Okay,
This is very quite common problem, but it is not a redundant problem.
Yeah. So, Santosh, there are a couple of other questions also. Some people have raised hand and some have written here. So, Nizamuddin ji, will you unmute yourself, please? I'm requesting you to unmute yourself.
Thank you, madam. Sir, I have designed a model for recognizing emotion using CNN and STN, and it gives a 72% result on FER 2013 dataset. But I want to test this on JFE and CK plus dataset. तो सर प्रॉब्लम क्या है कि क्या मेरे को मॉडल बदलना पड़ेगा या फिर मेरे को उस डेटा मॉडल को FER 2000 की 13 के बराबर लाना पड़ेगा, सो दैट मैं मॉडल ना चेंज करूं और मेरे दूसरे मॉडल उस पर ट्रेन होकर के टेस्टिंग में कर सकूं।
एक्सप्रेशन रिकग्निशन की बात कर रहे हैं?
जी सर।
You have tested your model on
FER 2013.
FER 2000, okay. FER challenge, you have trained the model, but you are trying to do the cross data validation with CK plus.
Right, sir. Right, sir.
And the performance was degraded, right?
नो सर, अभी हो नहीं पा रहा। 72% के लिए मॉडल बनाया हुआ, तो FER 2013 के ऊपर मॉडल बना हुआ था सर, बट अब CK प्लस के ऊपर टेस्ट करना था, JFE के ऊपर टेस्ट करना था, तो क्या चेंज करना पड़ेगा इनपुट लेने के लिए?
No. Actually, okay, I understand your question. See, the question here is, I think you might be taken a network which is already trained on the FER 2013, right?
Yes. That is a 48 by 48 images. Size is 48 by 48. But
input size of FER is not 48 by 48.
In FER 2013, sir.
Yeah, but it is not 48 by 48. But anyway, if it is a 48 by 48, suppose X model has trained on a Y data set.
Okay.
Where the input size is M cross N.
Okay.
During your testing, you have to use the M cross N data input size only. See,
okay, sir, but FER 2013 is a totally different data set, and CK plus
FER 2013 you are talking about is challenging data set, right?
Yes, sir. Yes, sir.
Yeah, that's what I'm saying. Challenging data set, where we have 2 different data sets on that. You can explore more on that. Where you can able to get the bigger size image data set 228 cross 228 is also available.
Okay.
So now, in which model you have taken, depending upon that, you have to change the CK plus also. Input size आपको कम करना पड़ेगा.
Okay, sir.
So logic is so simple. You have trained X model with some properties by passing the image as a smaller size image, but you are trying to test with the bigger size image. Your model will not going to train dimensional tissue, right?
The dimension, and that is a CSV file, and other is not.
Format of the file can be anything, but given input size should be matched. If you have
yes, sir.
112 cross 112 size image size you are using, then in the testing also you have to use the same size.
Yes, sir.
Yeah.
Yes, sir. Okay, so I'm going to change the size of image for each and every pictures. In other data sets.
Change the features. Just you need to suppose, let's assume CK plus data size image size is 100 cross 100. Let's assume.
Okay.
But your model has trained with the image size of 48 cross 48, for example.
Yes. Yeah.
But you want to test on 100 cross 100 image, you cannot able to do it. So you have to resize this 100 cross 100 image to 48 cross 48. Then you need to test.
Okay, sir.
Whether the results will be good or bad, that is a secondary issue. But this is a procedure we need to follow. But especially on this particular, I guess you might be followed some paper or article where they were trying to work on the tiny size images. Generally, expression images size is not that 48 cross 48.
Okay, sir.
Okay, thank you. So next, can we go to Femina Shiba? Please ask your question, last question, then we can go ahead.
I think
Femina Shiba.
I think you almost answered. I have a problem where I have a small data set for my medical images, because for that condition we cannot get many images, as those patients will be very less. So in that case, we can have this transfer knowledge where we can have a model so that transferred to the smaller data set. Will that work correctly?
Suppose you want to use the model for the smaller amount data set.
Yeah, data set is small now. So with the smaller data set, with the CNN model, I'm not able to get the good accuracy.
Yeah, have you done this augmentation? But
Yeah, I've already done the segmentation, object identification, but my accuracy is not that very good because my data set itself is small, the training data set. Yeah. So can we use this transfer knowledge for that?
If you have some results which are trained on similar type of data set, which is trained on big data set, is called image captioning here. So till now in the previous case we have discussed about on a single application, maybe image or video. Now we can integrate the two different models together, or two different concepts together to solve one particular problem. That is called image captioning here. So if you observe here, this is an image. You need to give a caption, because giving an annotation for a particular data is also one of the challenging cases. So here we are trying to make this image captioning based on your model has to understand what this particular image is. So in this particular image, how you can able to give a name, how you can able to naming this particular image, because there is a green background, it can be like a ground. There is a football and there is a skate. So there are three words are there. One is ground, kid and football. By combining three words, we need to form a sentence. That is called a kid is playing a football. So this is something called image captioning. If you can observe here, from a given input data, we are going to recognizing what these particular objects which are presenting in a given image. So background you have detected, that is like a ground. A kid you have detected kid. One ball you have detected, that is called football, right? Ground is a word, kid is a word, and ball is a word. By combining these three, we are going to form a sentence. So here we need to integrate the two concepts together. That is called image processing and natural language processing. By integrating these two, we can come to a conclusion, that is image captioning. What are the applications are there? We will discuss. You try to observe here. This is our campus, the Imagenet campus, where we have tested our model with this. I hope you are going to detect some mistakes here. So if you observe here, it is almost trying to caption each and every frame here in this example. But there is a small mistakes which this particular algorithm is giving. So observe this: a man standing on a beach holding an umbrella. So man is walking, but it is a frame-wise analysis. So his standing is correct. Holding an umbrella is also correct, but standing on a beach is a wrong thing. But now if you observe here, we have tested this particular model on publicly available data, but we have tested with completely unseen data. So this particular scenario which I have not even seen by our model during the training. But if I want to test the same model in the unseen environment, it is almost giving the 90% of the accuracy. but the 10% is because of this mistake of seeing a beach. So why it is recognizing it is a beach? Because the sand in the training model, wherever the sand is there, the corresponding sentences which are available during the training was a beach. So that is the reason this captioning, this particular video captioning, this algorithm is going to give a beach in between the sentences. So this is how we can able to train our model here. From a given input data, you can use some of the CNN models so that you can able to detect the number of objects which are present. So from there you can able to get some of the features. From the for given input data, we have some corresponding sentences are with us during the training, because for each testing data, each training data, we have corresponding captions are available. We also need to train by joining these two. So by using word encoding for the training data, we can get some features. You integrate these two, then you further train, so that you can able to get the overall result for the image captioning. To compare an object that must be present in database of, yes, because here whatever the image is there, the corresponding captions are also available in the training. How you can able to know, how you can able model to know what that particular image contains. So somewhere we need to provide the proper captioning information also. So by using the proper data, then only we can able to test, right? So as per your question, yes, for which application you are trying to develop a model, the corresponding captions also required. From where we can get this data? Yeah, that is a nice question. For the image captioning and image questioning answering, we have well-defined data sets are already publicly available. You can search in GitHub, and where you can able to get information, or you can check these corresponding papers on Google. You will going to get the information. There are many publicly available data sets out there. But if you want to customize this particular captioning or questioning answer system for your application, then you need to create the data and you need to create the corresponding captioning information during the testing, training. Sorry. Yes, that we need to do. If you want to do something for customization for as per your requirement, you need to do it. Okay. Now you see this particular image. For easy understanding of image captioning here, so this is a picture where we have n number of crowds, n number of objects are available here. There is a woman, she is holding a camera, and there is a woman wearing a purple jacket, and she is holding a camera, and this is a crowd. So first we need to recognize the number of objects. So once you recognize this is the object information, you got it: woman, crowd, cat, camera, holding, and purple. Now you form a sentences. So you can able to get the n number of sentences. Then use the ranking, which sentence is more appropriate to you. Then you can able to give a proper caption. Basically, a woman holding a camera in a crowd. So similarly, we can apply these particular things to n number of applications depending upon your requirements. And now this particular concept is further extended to visual questioning answering. This is also one of the interesting problem. Much research is already done in this particular field. You can find out more number of good articles in this also. So here, what is the malicious made of? You knew this. First, you need to recognize what is the malicious here, and you need to recognize what the particular object is. Here, the object is a banana. With the banana, the malicious made of, right? So such type of things also we can able to do it. Now coming to the expression. So if you'll observe here, these are the few expression data set expressions are available with us. That's called universal expression, you can call it as. So here, if by seeing a face itself, you can recognize what the particular girl is trying to express. So by seeing the picture itself, you can able to say she is happy, right? But the question comes here is whether she is really happy, or she is whether it's a real expression or a fake expression. That is a second discussion. But this is called expression. This called macro expressions. Why these particular expressions are somewhat important? If you can able to see, this is the scene. Here, these are all the people who are the sports persons and who are the might be singers from the birth. They may not able to see and learn the things, but still they can give an exact same expression like us. So now she can able to see this, I mean some impaired persons can also express the same expressions like the persons who have already having a who can learn something by seeing, right? So they can able to smile, they can able to feel happy and so on. So expressions are within us, but how we can able to fake it, that is different issue. So with the help of this, we can estimate some true emotions also, true expressions also. So this particular application is called macro, and further we can extend this to micro as well, and it is having many number of applications. That is all up to you. You can use it, this application, for your requirement, like e-learning, police testimony, online shopping, medical diagnosis, gaming, and so on, and classroom, group behavior, and these are all the fields where we can use these particular expressions. And there is another thing. Now you try to observe here. You see this video. Could you able to find out any of the variations? It's a live video which is going on. I mean, it is a video, recorded video. But if you will see here, you can find nothing. But you try to observe the variations here. Yeah. At this level, you see there is a minute variations you can able to observe, right? So you can observe the minute variations. But if you can able to see in a global view, everything looks very similar. Now you try to observe here. Can you recognize what type of expressions she is having? So here the same expression which is spread across, the single expression which is spread across, this is called the micro expressions. She is happy. Here you can able to see there is a small change in the lips. Similarly, you can able to see this particular expression, except this eyes, everything looks similar, right? So this is called micro expression. That means the variations which are going to happen only for minute interval of time. So this is called micro expressions. This is very challenging field of research to work. So as here, expressions in this case, the phase where we can have minimum variations, and also we have minimum number of data. The number of samples which are available in datasets are very limited. Then how to train our models? These are all the few articles some articles we can discuss here. So you can able to see this is one of the shallow network where we can also customize some layers. So in the beginning somebody asked how to decide how many number of layers are required. So not necessarily you need to, I mean there is no such parameter. As per my observation, there is no such parameter is there to define the number of layers. The number of layers and the selection of filters are purely depending upon the application and experimentation. But you can customize the layers. Yes, we can customize our own layers depending upon our requirement. Let's assume if you will observe here. So here from a given input data, initially we have used 5x5, then 3x3, then there some XFIT features the others have proposed. What the particular XFIT will go on to do? You try to observe here. This is a XFIT. So from a given input data, that means from here, the 3x3 responses we are here feeding as an input to this particular XFIT. You try to observe the XFIT here. Here the XFIT is 1x1, 3x3, 5x5, and 7x7. So multi-scale features are there. In a standard, if you can able to see the standard operations of convolutions here, the previous responses are simply going to be added. The previous response like 1x1, 3x3, 5x5, 7x7, simply you can add all the things together. Two options, either you can add or you can able to concatenate. So if you can able to add it, so if you observe how this is the response, you are going to get it. But here the other have done their own way of analysis here. Instead of going to use a simply addition, they have done some analysis within the multi-scale features where out of these 4, they have taken a minimum feature and also they have taken a maximum response. That means from 1x1 at a position at a 1x1 convolution operation, some residual field came, response came. Similarly, after 3x3, 1 response. After 5x5, 1 response. 7x7, 1 response. So total 4 resultant features you got it, right? Instead of simply summing of all 4, you can select required features from out of these 4. To select those things, in this article they have used out of 4 maximum pixel and out of 4 minimum pixel, then they have taken average of it. And the average response they have added to the previous response. So instead of simply adding all the 4, they have taken some uniform informations and they have taken the extreme edge informations at that particular location. And if you can able to see these elective layers by following this particular strategy, you can able to see the different features. So depending upon your application, you can also design some modules. You might be seeing most of the papers they have proposed. They might be proposed that in their article they propose some customized module, and that particular module might be performed better in their applications. And this is another article. If you can observe here, this is a very shallow and small network. This is almost 1 million parameter network. So here, using these layers is also one option. So if you can able to observe here 7x7 and red one is 3x3. So 7x7 and 3x3 filters extracted from given input data. Then the responses are going to be added from the resultant response. Again, they have done 5x5 and 1x1. And this is called one block. That is called high field block. And the same block in their article they have repeated 3 times. And if you go for if you read those articles, you can reduce these blocks by 2, or you can repeat this block by 4, 5, and so on, depending upon the application. So in this article, they have done some ablation study also by repeating removing the stack of 3 by 2 and increase by stack by 4 and 5 also. So if you'll observe here, these are all the features you may can get it. As we have discussed, if you can go for the sequential approach here in this example, the information may go into lose. Instead of going in a sequential manner, I want to go in a bit deeper, but also I need to maintain my features. So this is somewhat pictorial visualization of the problem. From a given input data, first extracted 3x3, then 7x7, you got some 2 different features. Then you add those 2 features, then pass this feature as an input to the next response, that is called 1x1 and 5x2. And at the end you can able to fuse these 2. And you can repeat this operation 3 times. By following a sequential, by using this high nets, the information can be preserved before going to the fully connector. If you have any questions on this, please you can discuss. Guys, if you have any question, please raise.
Participants, you again can raise hands, 1 or 2 questions you would like to take. Seems there are no questions here. You can go ahead.
So there will be another architecture where you can able to see it here. So if you'll observe here, this is different architecture. Now that's all up to us how we can able to design our network. Now you observe here. Let me give you the basic difference again with the other approaches. Like in the popular networks like VGC 16, 19, Resnet and so on. Initially, in those articles, if you will observe, the initial filters are 64 filters, 32 filters, 128 filters, and so on, right? So for the application like express recognition, using many number of filters may not going to help us. Second observation, even though you are using a 64 filters, it doesn't mean that all the 64 filters may going to learn. So some of the filters may going to learn, some of the filters may not going to learn, right? To make all the filters to learn, that is how this dropout concept came. But if you can observe here, 64 filters, instead of using in a 64 filters at the same depth, we have divided the 64 filters into 4 streams, parallel streams, 16, 16, 16, 16. So here, if you can able to observe here, there are 4 16 filters, that is 64 divided into 4 parallel streams, and you observe here at this location. The first resultant response of first filter are combined with the second parallel layer response. Similarly, third and fourth level responses are again added with the third level responses, and the operation is repeated for 2 times. So this is also one of the very shallow network, very lightweight network. This is also having 1.4 parameter, 1.4 million parameters, I guess. So this is one article if you will observe. So what was the intuition behind this particular algorithm? The intuition here is, please explain about the fusion mode. Okay, I'll explain about the how different type of filter merging works and what is the resultant filter size would be. Okay. Okay, I'll give you one intuition for that particular question. Okay, let me complete this. I'll come back to that. So observe here, 16 filters, 16, and here combining. You try to observe this particular visualization. There you will get to know. So this is the first. This is first, second, third, fourth, right? So observe here, from a given input data, this is the first 16 responses which we have got it from the first layer. So in 16, some of the filters have learned better, and some of the filters not learned from a given input data. This is the second 16 level responses, like this. This is the first one, and this is the second one. So in this 16, few filters have extracted the features and few filters may fail. But if we can able to combine these 2 responses together, the resultant response is something like this, right? So these responses are required for us to learn our model. If you can keep on trying to learn on this, because here everything is bit uniform, it will not going to learn. The resultant values will become 0, and you will not going to, the model will not going to converse properly. So by adding this, we can able to preserve the features. So this is the actual intuition of this. So from, if you can simply following this, the features may not going to learn, the model may not able to learn. But by combining or fusing this type of 2-layer responses and repeating this operation to the further, by reaching the fully connected, the information can be preserved. So this is a, will it add first with the first, second with second, and so on? No, it's not about first with first. Okay, I think I will try to write here. For your easy reference, I am trying to write. This is the first parallel response. This is the second. This one is third. This one is fourth. Now you observe here. Here I have used 16 filters. Initially 16 filters I have used. Here also 16. Instead of using 64 filters in the beginning, we have used these parallel stream networks here. Instead of sequentially using 64 in a single position, we have split it into 4 streams. And each stream we are trying to get the responses. So once your model has trained, from the 16 filters you got 16 responses here. From the second you got again 16 responses. Depending upon the properties of the filter, here you can able to get 16 different things, and here you can able to get the 16 different things. And now you see here, this is the first response. Here 4 cross 4. So here some of the filters might be not learned properly. It is learned, but it is not properly visible. So now here. Similarly, in another second level 16 filters, you can able to see these are all the responses which are not learned. But now see, here it is not learned, but here it is learned. Here it is not learned, but here it is learned. So if I can able to combine these 2 together, these filter response, if I will combine 16 out of 16, I may going to get it. See. Only one thing here also not learned and here also not learned, so the resultant response you didn't get here. But the rest of the things you got it. So this merging we need to do. That means we should have some our ultimate goal of designing any of the network is to your model has to properly learn, and you should give the better results for your application. But how to design a network is the first question. How to design a network is the first question. Therefore, we need to use such type of analysis. So visualization is also one of the important thing to while designing. Now coming to your first another question, that how different types of filters merging works here. Now if you'll observe here this previous thing here now. So here the intuition here is so simple. Let's consider this is your eyebrow. This is your eyebrow, right? In your face, this is eyebrow, upper portion is the skin and lower portion is the skin. You are trying to use a 3x3 filters. Let's assume 3x3 filter. So the 3x3 filter is small filter which is going to occupy this particular eyebrow region itself. That means within the eyebrow region, what are the information can be extracted. So as his eyebrow is itself is occupied 3x3, there you can able to get the uniform response. But at this location, if you want to go for the 5x5, either the upper skin portion and the eyebrows can be covered, or eyebrows with the lower skin portion can be covered. There is a chance of getting an edges at this location as well. So depending upon your requirement, do I need to go for the 3x3 filters or 5x5 or 7x7? And also you need to say, you analyze that if you are going to use only 3x3, only 9 parameters supposed to be learned. If it is a 5x5, you need to go for the quantified number of parameters. If it is 7x7, it's more number of parameters. But here, the thing is like, as per your application, what type of features you are trying to extract. Based on that, you need to go for the filter selection. Third one. Now here, as the question here is how to merge them. How to merge them? Because if you apply this image here, let's assume image is 100x100 and 100x100. If you are going to use a 3x3 convolution without padding, the resultant response is 98x98. Am I right? If you are going to go for the 5x filter, it is something like 96x96. So you cannot able to simply merge these two, because the output of 3x will become 98x98. Output of 5x filter will become 96x96. So you cannot able to simply add them together. In such situations, you need to ensure the feature response dimensionality also you need to ensure. That means you may need to require to use padding operations. At 3x you don't want to use padding, then 5x you need to go for the padding. Therefore, the resultant response size will be equal to 98x98. So those decisions you need to take while developing a network. So here you can able to observe the things. If you can able to extract different features here, you can able to get the overall edge information from a given face is clear. Now you observe here from here and here. I hope you are clear on this. Any specific questions, please you can discuss. Any questions? Will it add first? No. Okay, we have already discussed. Okay, fine. If you have any question, please raise your hand. So this is one article. It is in transaction image processing. If anybody interested, you can explore on this. No, this is another article. Here also you can able to see different network designing strategies which are adapted. So you may can ask that the previous network part we have discussed, it may not going to perform well in this another application. It is a similar application, but here the things are different. But in this application, we need to extract some of the motion information also, not only spatial, also we need to consider some of the temporal variations. So the active imaging, some concept we have which you have used by these others, and the resultant response they have used the shallow network, because the ultimate target of this particular application is to design a lightweight and shallow networks. And this paper got accepted in IGCNN conference, the Korea conference. So there you can test. these models. So here you can able to see this is one very small network, 3 cross 3 and 5 cross 5, only 2 filters which they have used and repeated for 3 times. Very small network where 3 cross and 5 cross 5 they have used and combined and repeated by 3 times. This is on expressions, and there are many articles that you can, if you're interested, you can explore on this. And the third one which we can go for this change detection, it is called moving object detection concepts here. So in this example, if you can able to observe, this is a standard way of solving the problem. So in this particular standard way here, see, this is a video clip here where you want to segment only the moving objects. If anything which is non-moving, is a stationary, you can consider them as a background information, because here the floor is a background, so you don't need to specifically detect them. Here the cars are moving and here the persons are walking, and the person is trying to hold his bag or removing or keeping his bag down, right? So you need to segment only the changes which are happening with respect to time. That is called moving objects. Now in recent times there are a few other articles also available doing the similar task with the bounding boxes. This particular concept we can discuss later on in further sessions. So let's discuss some of the article designings on this particular change detections. And this is the further applications of video analytics where we can use this particular segmentation and the bounding box concepts in other few applications also. Those applications are something like this. Intrusion detection and the traffic monitoring. This is one of the interesting problem of traffic monitoring, where you can also find out the abnormal driving behaviors here. So also you can find out the not only traffic monitoring, you can also observe the if there is any abnormal driving behaviors are there, you can able to detect them also. So here the person is not giving any particular indicator, but still they are trying to change the lane in this particular traffic condition. So it's the abnormal behavior. Now this is one of the interesting problem of violence detection. See here, how you can able to define the violence. Violence is depending upon the actions, right? Here the person is holding, wearing a mask, covering his face, and he's trying to aim a gun towards a shopkeeper, right? So as the person is trying to hold a gun, and this posture and this action and the object which he is holding, based on this we can able to say there may be a violent activity is going on, so you can able to detect the violence. But the same case may not going to true in other conditions. That let's assume the same action is appearing in a gun shop itself, then can we say it is a violence activity? So in this case, this particular action and the detecting this particular object, combining these two, we can say that this is a violence detection. But the same algorithm may fail whenever during the background the shop itself is a gun shop, because there he might be testing. It is a normal activity. So violence detection is an application where we can work, and which is an interesting problem, but there the background information is also an important parameter to take a final decision. So integrating different solutions, we can able to take the final call. And this is anomaly detection is one of the interesting problem. So here the first challenging problem is defining the anomaly. So defining an anomaly is the first challenging problem. Once you are clear about the defining the anomaly, then we can able to make we can run our algorithms. And regular video surveillances where we can use this particular forensic analysis purposes only. And the third one is like crowd monitoring, especially in our COVID situations. This is one of the interesting problem where people are working. That is called crowd monitoring. In this area already before also working, but during this pandemic it is much attracted field, and it is having many challenges also. Now in the crowd monitoring, by using the crowd monitoring also we can take the decision of whether is there any anomalous activities happened or not. Because in a particular shopping mall, let's assume the crowd has gathered where to participate in concert, it is a normal activity. But the crowd has gathered where there may be a small accident or anything, then it is an anomalous activity. So analyzing the crowd, we can able to further classify whether the where in the particular location the activity is anomalous activity or normal activity. So that also we can work. And the another interesting problems are here in the object detection. If you'll observe, so there are many good algorithms are there in the object detection as on a regular use. And there is another algorithms are also available, that is called from the aerial view, because here the challenges are completely different. So here the objects are going to be detected with the help of these bounding boxes. So you can able to observe the green color square or rectangular boxes here. You can observe here. So here the bounding box is going to say what type of an object it is here. With the help of bounding boxes, we are going to detecting the objects. So the algorithm perform better in this in left side may not going to perform good results in the right side and vice versa. So the reasons here is, if you will observe here, in the left side in the regular view, a box which is going to occupy a bigger size, here the object in a frame is occupying more space as compared to the right side. So here one bigger bounding box is required to detect one particular object in the left side. But in the right side, as these objects are very smaller in size because it is from the aerial view, to detect an object, you need a small bounding box. So if you observe the same, if you use this particular right side algorithm on the left side, the small bounding box is not even covering a 2% of the car. So these algorithms may not going to perform well, and vice versa. If you can able to use this bigger bounding box strategies on this example, so one bounding box is going to cover more than 5 or 6 objects. So that is how there are few researchers are trying to develop an algorithm which is going to balancing these factors. So the same algorithm is supposed to work in the aerial view as well as on the regular view. And there are a few more also algorithms are available to further handle the challenges during the detecting the objects, like low intensity in the lightning conditions and all. Those things we can discuss in later things. So this is the aim of the algorithms to detect the objects from the aerial view. Let's talk about one of the network architecture and how the changes of the architectures are happening in this particular field of change detection or moving object segmentation concepts. So this is one paper in 2018. This is one algorithm where you can able to see from a moving object detection. First, people have estimated the backgrounds first, because once you know the background, you can subtract the current frame. If information is similar, then difference will be 0. If there is any dissimilarity, you make an estimate that there may be a motion is involved. Right? So this is one algorithm where people have done some background estimated manually with the help of conventional approaches, that is called temporal median. And those those techniques have passed to some small encoder decoder network. So the encoder decoder network is something like this. It is one of the small network. So further, and they have tested their models on one of the popular dataset called CDNet 2014 dataset. So they have divided this data into training and testing. So from where you can observe that the data has scene dependent or independent. This is one algorithm of scene dependent data. But the same, but in this algorithm limitation here is they have used a temporal median as an input. So that means it is depending upon the traditional approach as well, right? Further, from the similar group, there was an alternative approach they have proposed in one of the IEEE transaction. This is the first algorithm in the field of change detection, moving object detection. As per the article, it is the first algorithm where they have produced a complete end-to-end solution, input to output, without using any of the handcrafted approaches in between. So the idea is something like this. If you can observe here, you can observe here. First one is, first we need to estimate the background. The estimation of the background, you can apply any application wherever you wish to do it. The concept of estimating background is remains same. So first we need to estimate the background. So from a given input sequence of, here they have taken the input sequence of 50 frames. From a 50 frames they have come down to 1 frame. Now from the 1 frame they need to estimate the saliency motion. Saliency motion means from a estimated background, do we have any changes are there in our current frames? So they have subtracted these input features from the estimated background. So in order to subtract, they have used a concept called replicated layer here. So here the background is estimated as one single frame. Then they have repeated this particular single frame to 50 number of times. That is called a replica layer. Then they concatenated the current input frames with the replicated layer alternatively. Then they have gone for the differential layer. So that from a current frame, whatever the model you have estimated, you take the difference between these two so that you make it able to get the changes. If you find out some changes, that means there is a motion is involved. So they have used this differential layer, then they have gone for the max pooling, then they have do the encoder decoder. So encoder decoder remains similar concept, but here this is the first algorithm in the field of change detection where they have provided a complete end-to-end solution to solve the particular problem. And of course, this model also they have tested on 2019, CDNet 2019 dataset. But the problem here in this example is like the content they have used for the training and the content used for the testing are having similar properties. That was a drawback, but otherwise this is the first article in this particular field of change detection as per this particular August client. Further, to avoid this type of problems, we need to propose, or we need to develop an algorithm which has to work perfectly on the unseen environments. That means whenever you're going to train our model on a seen environment and testing our model on the unseen environments, there are many technical issues are there. In order to surpass that issues, people have implemented some models on the scene dependent environment, but that is not supposed to be the case we should follow. So this is one algorithm where they have proposed a completely unseen environment, and also they have proposed the limitations and all. This is the article, you can go for it. Scene independency matter, it is IEEE transaction table. So here if you observe here, the background need to be estimated. So in order to estimate the background, here they have proposed one model called MMSR block. As I said, you can customize your filters and you can customize your modules, and that module specifically going to perform something as per your application. So in this example, they have used this multi-scale features of 1x1, 3x3 and 5x5, but here they have not even neither concatenated nor they have added. Instead of these three, they have extracted the max out of these three. Neither concatenation nor added, simply they have picked out the maximum value at that particular location from these particular three filters. So at a depending upon the properties, maybe sometimes the 5x5 will go to give the maximum value, sometimes the 1x1 may give sometimes 3x3. So here the intention here is to extract the maximum out of the given input filters. They have taken this max operation, that's called MMSR. So MMSR is nothing but maximum multi-spatial receptive features, and they repeated this operation for 3 times to estimate the background. Now the question comes here is, here the input sequence is 50, you are trying to get a single output, how to come down to 50 to 1, because his temporal depth is also an important parameter here. So here they have gradually reduced the depth, that is called DRB, that is called the depth reductionistic background estimator. So you need to reduce the depth of these particular frames with the help of the filters, so that you can end up with a single convolution operation, so that you can able to estimate the background. Now from a given input 51 frame, you can consider as an input frame, so that you need to estimate the changes, that's the salience information. So in this article they have used the same MMSR block here, and these two are going to be concatenated here, because the estimated background and information which is coming from the input frame, and there is a temporal median. You combine all these three together, that is called CFA, coarse feature assimilation block, and you pass it to the encoder decoder. So this is a pictorial visualization of this particular module here. As I said, the DRB depth recognition block background estimator. Here is the temporal sequence history frames. First MMSR, so you can able to see here, there is a changes here. You can observe in the first MMSR block. Wherever the changes are there, edges and all, you can able to find out. Later on, we are trying to slowly smoothing these filters in such a way that only the background information is supposed to be preserved. So in order to smoothing this, we have repeated this operation for 3 times. Tested the model with 4 times also. Those things you can able to check in the evaluation study. So here the filters you have repeated for 3 times. So ultimately you got this particular background. See from a current frame the similar features of MMSR. So you can able to get the foreground and you combine and you can able to get the contrast feature assimilation. And these features you can able to further pass it to the encoder decoder. Now in the similar flow, there is another article. Okay. This is a first article which I actually clearly given the technical differences in the existing articles and what are the what is the solution supposed to be followed. You can able to find in this particular article. So this is another article which is published in transaction image processing. This is a completely 3D CD. 3D CNN model has used here to estimate the to segment the foreground information. So there they have used GRB block that is called gradual reductionistic background estimator, and FSR is called foreground saliency response here. Now you observe here from the 3D here, instead of using a spatial temporal pooling, here they have used a spatial pooling. Here in this case they have used a temporal pooling concept. Because here we cannot able to do this particular spatial pooling, so they have used a temporal pooling concept here. Initially they have used a 50 filters, then they have done the temporal pooling with 5, they come down to 10 filters, or temporal depth of 10. Then they have done the temporal pooling of 2, so that they come with the 5 filters. Then they have done a temporal pooling of 1, so temporal pooling of 5, they have end up with a 1 filter. So this is also gradually they have reduced the temporal depth of the input features to a single feature, because we need to estimate the background from a given sequence. So the salience information, as I said earlier discussed, we need whatever the model you have estimated, simply you can able to take the subtraction from the current frame. So whenever you are trying to take the subtraction from the current frame, you can get the changes. That is called CMF, post motion features. But there may be a chance of noise can be detected, because noise, whenever you're trying to get the difference, the noise can also be available, or some unwanted information can also be available. In order to further remove that, they have done this further convolution operations, so that from a given input data some convolution operations, and from the CMF again they got the convolution operations. Okay. Now second convolution operations. So whenever you are going to do these convolution operations on the saliency map information, the noise and all unwanted information may go into surpass, so that the actual true change information can be preserved. So this is the purpose of this FSR. So here you can able to see this. The ultimate aim is to get the motion information, that's called coarse motion feature we need to extract. But as I discussed that there is a information can be having a noise or unwanted information, to remove that surpasses that they have done some convolution operations to smoothing this information. And further you can see this, they also proposed the extended version of the encoder decoders here. In the literature, if you can see, most of the works they have used this multi-scale, multi-layer parallel stream networks in the encoder, but in the decoder they have used single stream. But in this article they have used this to maintain the similarity. They have followed this multi-stream networks here in the encoder, also in the decoder. Yeah, if you observe here, so here the what are the multi-scale features they got it. They have used some residual connections so that the features can be preserved or learned. If you observe here in the decoder, wherever you have got this multi-scale filters, they combine here. So all the combined features we may not able to use it for the testing. To check the accuracy, you need a single image. From a given input image, from a given input sequence X, you need to generate the X prime. But as you're trying to combining here, the noise information also present. So in order to further surpass this, they have again used the 2 more convolution operations here, so that the information can be smoothed. Only the forward information can be preserved. With that intuition, again the CFD module has introduced here at the just before the decoder output. So these are all the theoretical approaches we need to use before developing any of the network architecture. If anybody working on this particular area, if you want to know more details on this, please visit my website where you can able to get this all information, and you will get some of the review articles also in this particular field. And there we have suggested the limitations and advantages, disadvantages, and so on. Who are newcomer, for them it can be useful. So this is one pictorial visualization. You can observe here from a temporal sequence, we have estimated the background. From the background, we need to estimate the coarse motion features, so that the subtraction of estimated background and current frame. From a coarse motion features, we have again done this particular encoder decoder. You got some output. After applying this CFD, because fine tuning of the responses, we have end up with the results, forward information. So as I stated that here, the change information that the object detection or moving object detection, this is a conventional way of solving. So there was a new type of an algorithm which is available, that is called MOR, that is called moving object recognition concept. That means you can detect the bounding boxes, you can detect the moving objects not with pixelized binary segmentation strategies, but using these bounding boxes. So this is a new algorithm, so that you can able to use these algorithms at your customized environment. So this is the first article in this particular field to provide a solution with the help of bounding boxes. Moving object detection with the help of bounding boxes. We're going to discuss this in later classes. So another interesting problem where we can I'll give you the brief overview, that is called anomaly detection. So in the anomaly detection, if you'll observe, here also few articles are there with the help of transfer learning. In the anomaly detection, what is meant by anomaly? Anomaly is nothing but something which is not having a normal behavior. So if you'll observe here, it is following some normal behavior, but at a particular time, there is a sudden peak. So this sudden peak is not a normal behavior. So it is an anomalous activity. It is an anomalous behavior. So we need to develop an algorithm so that we can able to detect the anomalous activities in a given data. As I said, anomalous activity is one of the biggest issues. Compare these two images. Which one is anomalous to you? So this is also boxing, and this is also one type of. This is also fighting with boxing, and this is also the action is also like a boxing. But here, this in the right side it is an anomalous activity, but on the left side it is a normal activity. Why? The reason here is not the action. The reason here is the where this particular action is happening. So in this left side image, the action is happening in a boxing ring. So this particular thing is a normal action, but the similar action is happening on the metro train. Then it was an anomalous activity. So in the anomalous thing, which we need to also analyze that what is the action and where it is occurring. So in order to understand where it is occurring, the background is also an important aspect. Similarly, these are the few other examples of anomalous activity. And you can use these applications in wherever you want to apply. There are many applications are there in anomalous activity, like car parking is anomalous activity, and in industry to detect the false products, we can use this anomalous activity. So this is one of the interesting problem. This is a pedestrian data set you can consider here. This is the path for the pedestrians, not for the cyclists, not for the bike riders or car driver. But here in this particular pedestrian path, there is a cyclist. He is trying to do the cycling here, and there is a vehicle which is moving here. So these two actions are anomalous activities here in this particular application. So we need to define the anomalous activity, then we need to develop an algorithm. Similarly, if you can able to see every year from 2018, in CPR conference there is a challenge which is conducted by NVIDIA, that is called AICT challenge in 2018. But in 2019 they have proposed one big data set. By 2021 the data set has already increased and they also introduced many challenges. So in this data set, if you'll observe here, this is a anomalous activity detection on highway environment. So on highways, you need to detect the anomalous activity. So here, the defining the anomalous is the biggest challenge. Their definition of anomalous activity here is, on highways, the vehicle should not stop. As per the rules of the highway, the vehicle should not stop. If the vehicle has stopped, that means there wasn't some issue was there. So to detect such type of things, this challenge they have introduced. These are the few properties of the data. And they have considered many challenges like slow motion, illumination problems, cars in parking area. Because if you can able to see here, there are a few cars which are there in the parking lot. So which are there in the parking lot here, you will observe. And you observe here, there is a small patch is there. Patch is here. So this patch sometimes will going to detect like an object. So that is a problem. And occlusions are very common problem, and slow motion of the vehicle is also a problem. These are all the problems which they have already introduced. So you need to provide one of the solutions. Now you try to understand what is meant by anomalous activity, what actually you want to do. So now here observe here, this is a moving vehicles are there, but there is a vehicle which is not moving here. You observe here. So first you are trying to detecting the anomalous activity. Now you see. So now you are trying to detect in the background. Whenever you are trying to detect in the background, the vehicle which is there on the vehicle which is not moving will come onto the background, because this is a background estimation. Background is something which is not changing. Now observe here on the left side there is an accident that happened. So whenever the accident is happening, there is a much disturbance. Now you try to observe here. So the vehicles which have disturbed and which are not moving now comes under background. Now if you observe here, there is small synchronization issues there in this example. So if you observe here, right side. So whenever the accident is happening, there is a sudden changes are happen, and whenever the things are getting normal, now the things are getting normal here. Now you see, as the time goes on, the number of vehicles are going to be stagnated here. The traffic has all the vehicles have stopped. So now all the vehicles are comes under background here. Now you see in the right side, all the things are coming under background information. So this is one way of solving the anomaly detection. And we can also detect the what is the timestamp of this particular anomaly detection, where this particular at particular what time this particular anomaly activities happen. That also we can able to detect with this particular algorithm. So in order to solve this, let me give you just basic understanding of two algorithms. So this is one of the transfer learning algorithm. From a given video sequence to extract the spatial information, they have used VCC 19 architecture. No training, simply they have taken the VCC 19 architecture to extract the features. To estimate the motion information, they have used this optical flow, and with the help of this motion net and what are the features they got it, they have combined these two features and they have trained the further training. So the VCC 19 and motion net features are taken from the trans-learning weights only they have taken, and they freeze the weights and they have trained the model. And this is another article which I have talking about the CPR workshop. So they have used this particular 3 different steps here. First one is the background modeling, second one is the object detection, third one is timestamp aware anomaly detection. At what time the particular anomalous activities happen. So first one is background estimated. So in order to estimate the background, the simple encoder decoder concept has used. So this is a simple encoder and this is a decoder concept. Once this particular encoder decoder is over, the second one is a tiny object detection. So here we need to detect the small size objects. So in order to use this tiny object detector, they have used this particular thing is like YOLO architecture. YOLO architecture they have used to solve the problem. Now observe here from a original sample here. Now observe here. This is a original sample, original video, corresponding backgrounds which are estimated, and there is a small. Everything is correct here because there is no vehicles have stopped here. This is also vehicle has not stopped. So things are perfectly fine. So in this example, nothing has stopped, so there is no issue. Now you observe here, the vehicle will going to be detected here. Yeah, you observe here. Initially, here there is no vehicle. You check my mouse here. Initially, there is no vehicle is available. So as the vehicle is not available in the background, nothing is available here because everything is moving. Here the things are moving. So here in the anomaly detection video, nothing has detected because nothing has stopped. But if you will observe here at this particular timestamp, there is a small one vehicle which is coming and is trying to stop here. Then the moment of the vehicle has stopped. So the time the moment of the vehicle has stopped, now it is comes under background. So in the background the vehicle has detected. So now this background image we have passed to the object detection. Here the object is detected. So this is one approach where we have where this particular other have proven the work. So also you can able to see this is a small vehicle which is there in between the road that is not moving, and this object also going to be detected with these tiny objects. Now there are some false positives also there. Now you observe here, the things are moving on the left side and background also exactly detected. There is no issue. But this algorithm has failed to detect these false edges because if you will observe here there is a small patch, and this patch is appeared in this particular background. Now this patch is so small in such a way that it is going to create the model has confused to differentiate this patch and a small object like a car. So this particular problem was also there in the what are the algorithm which we have shown earlier. So this is another way of solving a problem of anomaly detection, and this particular challenge is going to happen for every year in CVPR. If anybody interested, you can verify that. Okay, thank you. If you have any questions, please you guys can discuss.
Thank you so very much, Santosh. It is always pleasure listening to you. Questions, participants? There is one, Ashwin Yadav. He has raised his hand. Request Ashwin, please ask your question.
Am I audible, ma'am?
Yes, very much, very much.
Dr. Viparthi, one question regarding this. Generally, like we talk about what is the estimating the minimum training data set. So one approach, is it valid because there are no fixed answers? So we keep increasing the training data and see what MAP we achieve, and then graph it or plot it, and then thereby we can estimate the number of minimum images required to achieve desired accuracy. Though it is a rough approach.
Sir, whenever we have a minimum data, actually this is one of the biggest challenging thing.
Yes.
We are also trying to exploring on to solve how we have a minimum data and how to solve it there. But there are few algorithms are there that also we are going to discuss in the last day of the session. Whenever we have a minimum data, how we can able to solve the problems.
Not
succeeded.
Yeah, my question is basically like we want to train the model with the highest accuracy, to achieve highest accuracy with the least possible data. So one doesn't know how much that number exactly is. So that is why I thought probably one could keep increasing the training data set and see the improvement in the achieved accuracy, and then plot it, and thereby one can estimate that okay, if I want 90%, then I'll require these many images. Is that
But sir, I understand your intention, but the question here is that as such, there is no such measure that to get X accuracy, you need some amount of P percentage of data is required. As such, there is no measure. So that can be one approach may be tried, but it may not be a general solution for other applications, right?
Okay.
So we can't conclude.
Thank you.
Yes, sir. Any further questions if you want to ask?
Yeah, there are two more hands raised. Kalpana ji, you please unmute yourself. Kalpana?
Yes, sir.
Are you
Yes,
there?
ma'am.
Yeah. Yes.
Sir, but what is the basic difference between the framework and the model?
Plain?
Framework and model?
Yes, sir.
Framework.
Ma'am, it is
Framework.
terminology to say. Framework is a complete end-to-end solution. Suppose for X application, you are passing an input and you are trying to get an output. The things which I have used in between, everything is like a package. Generally, that we can call it as a framework. Model or module? What you said?
So, I couldn't hear you, Santosh ji. If
They are asking about the framework. What is the difference of framework and model or module? Something they ask.
yeah, so model is a single, like,
Network.
you know that it's a single piece, whereas framework gives you options for changing the
Yeah.
components, right? Whereas model is everything is frozen.
Yeah.
Framework will give you an option like which classifier do you choose. It can give you some pre-processing element. It can be processing element. And so for each component, what if I hope I have understood the question correctly, and I'm so sorry. There was some voice breaking, so that's the reason I am responding. Is Santosh there?
Yeah, ma'am. I'm
Oh,
hearing.
you're there.
Yes.
So perhaps today my network is a little weak.
No, I also didn't hear her question properly. I mean, what are the?
Acha, okay. She was perhaps asking for.
Yeah, yeah.
Kalpana ji, is this your question? What is the difference between a framework? Framework provides you like it's a full, like you have flexibility to change different components. I don't know if she's there or not. Then this is HTC. You have not written your name correctly, but I am unmuting yourself. Please, HSTC. What is your name? Please tell.
Yes, sir. Yes, ma'am. My name is Anjani Kumar, ma'am.
What is your name?
My name is Anjani Kumar, ma'am.
Okay, Anjani. Yes, please.
Ma'am, can I use OLO for defense object detection in case of long range object and some aerial vehicles?
Yeah, that is what we will going to discuss on the last day. That is one problem we will discuss. That whatever the objects you have detected in a normal view, and those objects may going to, those algorithms may going to fail whenever you are applying in a aerial view. That is what the reason I have explained on this particular slide, that the YOLO algorithms are what are the Retrieval algorithms. They initially have focused to solve these problems. Yeah, this particular slide I was talking about. So in order to solve aerial view, of course, here they have used the existing concepts of YOLO or Retrieval concepts, but we need to make necessary changes, which may going to perform better in the aerial view. We need to use it, but directly, simply, you may not going to blindly test on the another application. Of course, we can use it.
Yes, sir.
Is that question is clear?
Yeah, I think. So basically, more on this, you will listen from him on the last day. Okay.
Few architectures we will going to discuss, and a few other new solutions also we will going to discuss in other applications. I want to ask what is.
So one more.
So somebody is asking that Dipesh, yeah, Dipesh ji, the purpose of segmentation is like generally that whenever you want to finding out any of your region of interest, that means you have a bigger image and you don't need to focus on everything, but you want to focus only on a particular region. Only that particular region information you want to extract, there we can able to use the segmentations. You can apply this concept of segmentation in many applications, depends upon your area. For example, some segmentation concepts where trees can be segmented. Similar in content can be segmented into one area, and cars can be segmented like that. So we can use it, but where to use it is all depends upon our application choice. You have written something in, this is what your question or something else you want to ask? Yes, okay, fine.
So slides will be available. Some people are asking for slides. Don't worry about it. If there are no questions, further questions, we thank Dr. Santosh Vipathi for his such a wonderful session. And it is, as I say, that's always, we get something new listening to you. So Dr. Santosh, on behalf of IIT,